All right, folks. Hope you all are doing well. Monday. Sorry I couldn't be here, but basically, what I want you to do is go ahead and um, watch this video. So hopefully you're here watching this video. Take a look at some of these examples, and then I have a check for you to do. You'll see both of the things in the folder, this video and your check for understanding, basically, right? It's a 7.3 special cases check, right? And so what I wanted to do with this is we are going to take a look at, it's more multiplying polynomials. So you actually, guys, you did this on the quiz. We'll talk about the quiz presumably on Tuesday, tomorrow. But there are some special cases where things are going to look a little different. Things might disappear. What that means, we'll talk about it right now, or I'll talk about it right now. So just wanted to give you some examples here, all right? These examples are going to look very similar to the ones that you are doing on your check for understanding, right? So let me use this one as my first example here. Let's do this. Let's do 3 squared plus 2 and 3x squared minus 2. So you'll come across a problem like this, and it's going to tell you to find the product. This is multiplication, obviously. In between, there's no sign. And so we are going to multiply these. Up to you how you want to do it. You can use the box method. You could use the FOIL method, as we called it. Whatever you want to do. I'm personally, I think I'm going to use we call them generic rectangles. I often call it the box method. I'm going to use this. And again, it's 2 terms times 2 terms. So, and already you should hopefully notice something kind of weird going on here. These look very similar. One's plus, one's minus, but they look very similar. So let's go ahead and do this and take it one step at a time. I have a feeling you guys will be just fine to do this. Just wanted to talk about a couple of things here. So 3 times 3 is 9. X squared times x squared. How many x's are there? There are 4. 1, 2, 3, 4. Just count them up. When you multiply, you just count up how many x's you're multiplying. And since this is 2 x's being multiplied, and here's an additional 2, it's 4. Okay. The other way you can think about it is we're adding the exponents. When we multiply, we add the exponents. Kind of weird. I know we struggled with that a little bit last year for my folks who were with me last year, where we add the exponents when we multiply them. So 2 plus 2 is 4. All right, let's keep moving. 3 times 2 is 6. There are 2 x's. No x's with the 2, but there are 2 with the 3. 3 times negative 2 is negative 6. X squared. And 2 times negative 2 is negative 4. Okay, now these problems are going to look very typical to the ones that we do. The reason these are special cases, though, is, and I'm sure some of you guys see it, these are going to cancel in the middle. And so all you're left with is 9x to the 4th minus 4, and that's your answer. Not really anything special, but this right here is called our answer is called a difference of squares. We'll talk a little bit more about that at some point, I'm sure. And it basically just means that it's more something down the road when we talk about factoring that you're going to need to know that this is a difference of squares right here in blue. But more or less, it's more just important that you are able to do the multiplication. When we go backwards, we'll talk about the difference of squares, but no, the difference of squares, this happens. The middle term cancels, and that's happening because of the plus and the minus up here. The plus and the minus, when we do that middle term, they're going to cancel, all right? Now, this is not going to happen all the time. Don't assume that that's going to happen for every problem. Here's an example of one where that's not going to happen, and here's why. Again, multiplication. The squared indicates that there are 2 of these. Okay? And I'm going to go through the process, and I'm not really going to talk too much about it other than to say that, you know, again, these look very, very similar. okay? But don't assume that just because something looks similar that things are gonna disappear. Let's go ahead and go through it here. 36x to the fourth, negative 6x squared, negative 6x squared, and then negative 1 times negative 1 is just a positive 1. Okay? Line it up, and you can see nothing's going to disappear here. And I actually did this. This is one of the problems you're going to end up doing. So I meant to change it up. I forgot. Whoops, that's a plus. Sorry, that's a plus. Plus 1, right? Positive 1 plus 1. Sorry about that. So yeah, so the lesson here is just don't assume. These both look very similar, right? But this one is called a difference of squares. This is a special one where the middle disappears. This looks like, it's squared. It's minus, or it's a minus. So it's like it's the difference. Don't assume though. This is not going to be like a special. This is not a special name. Okay. So I think that's really all I have for you. Yeah, just when you have these different, when these two things look the same and they have different signs, canceling is going to happen. When they have the same sign, no canceling is going to happen. That's basically the biggest difference there. That's all I have for you. All right. Make sure you do the the 7.3 special cases check. No need to show your work, but you should probably have some kind of paper out while you're doing it. Other than that, ladies and gentlemen, take care. Hope you guys have a great day. I'll see you guys on Tuesday.